In this video, we are going to solve a problem based on acid-base theory. In the reaction HSO4 minus plus OH minus gives SO4 2 minus and water. The conjugate acid-base pairs are. It is very simple problem. If you have some idea about conjugate acid and base, you can solve this in no time. Let us consider a reaction between acetic acid and sodium carbonate. Acetic acid is acid and this is base. In fact, this is weak base, not very strong base. Sodium carbonate will abstract the proton from acetic acid to give acetate ion. In fact, we get sodium acetate. Also, we get sodium bicarbonate. Base abstracts one proton. After that, we get sodium bicarbonate. You may know sodium acetate is base. What about sodium bicarbonate? It is very weak base. Compared to sodium carbonate, it is very weak base. In fact, this has one acidic hydrogen. This is the structure of sodium bicarbonate. This hydrogen is still acidic. Sodium acetate is formed from acetic acid. So this is acid, and after abstraction of hydrogen, what we get is a base. So this is conjugate acid and base pair. This is the conjugate base of acetic acid. Now let us compare sodium carbonate and sodium bicarbonate. Even though it is slightly basic, it has acidic hydrogen. This is base and this is acid. So these two are conjugate acid-base pairs. Now let us go to the given option. Sodium bisulfate or sodium hydrogen sulfate. When you abstract one hydrogen from sulfuric acid, what we get is this one. Here we have one more acidic hydrogen, so this is acid. To this we add base. A strong base is added, say sodium hydroxide. It is strong base. This is basic enough to abstract this proton. After the abstraction, what we get is sulfate ion and water. This is acid. This hydrogen is acidic, so this is basically acid. After the abstraction of acidic hydrogen, what we get is base. So these two are conjugate acid-base pairs. OH minus is base. After the abstraction of proton, what we get is water. Water can give H plus. So this is acid. This one is base. So these two are conjugate acid-base pairs. Now let us go to the options. In the equation, we don't have H3O plus, but it is given in the options. It is not possible. Similarly, in the last option also it is given. So easily we can eliminate two options. Let us consider first and third. Here HSO4 minus, this is acid. Its conjugate base is SO4 2 minus. Here H2O is acid. This is conjugate base. So this is the correct answer. Third option, HSO4 minus and OH minus has been given. OH minus is not conjugate base. It is base, but it is not conjugate base of HSO4 minus. So this is wrong option.